So how do you fix this big problem here? So this is stating that's about 3,000 to 1, basically, PET to PLA. And so what you need to do is just go back to the start again. And so that's how you always do RIs. You start with the data. So I was originally going to just deal with that issue. And so I just got 3 data sets from proper journals and that show the PLA CO2 release. And of course, it now makes sense because it's kilograms of CO2 per kilogram of product. And the 3 values are all between 1 and 4, somewhere between there. And you can see the PET, like it's sometimes, double, not 3,000 greater, but twice as high. This one's, about 6 times higher. This one perhaps just double again. So it's not 3,000 times higher. It might be twice as high. Which is more realistic. But that data is not that great, bar graphs and stuff. So I thought it's much better. Again, you just have to start again and get 3 good data sets. So I thought this one's much better. What is the effective time on the release of CO2 from polylactic acid over a period of 100 days at room temperature and pressure? So one dependent variable, and a couple of controls. So I got here 3 good data sets. You can see this one is slightly different because there's different microbes and stuff showing that the release, and so it's about 6, this one's only about 6 grams per of CO2 released, and these ones are slightly higher. These ones go up to like 20 and 25. And this one here, well, it's slightly higher. It's like 12. And that's because these ones are on films and nanoplastics, nanoparticles, and so there's more surface area. And so you can have a much better idea of the fact, because you can kind of see it here, that there is a big factor in how much CO2 releases, how much it biodegrades, as opposed to this and this. So you might want to put that in your rationale, some of these graphs perhaps. As to why you're going to focus just on PLA and not PET, and just do one. So you're not going to do an A versus B. You're just going to choose one or the other. And so some of these graphs, maybe all 3, might actually be useful. And then that will sort of tell you why you're going to do this. So this one's got different enzymes, so that's part of your unit 3. And this one's nanoparticles. So it's all good part of your syllabus, and you can get down to chemical structures. So yeah, you've got 3 data sets, and you can show a full understanding of what's going on, rather than just jumping out of nowhere and not being able to really prove your case because you've just chosen one thing and not analyzed it. Okay, so that's how you fix it. Get 3 good data sets that are the same, one independent variable, and your scientific analysis will be much improved.